Well, you all know what are categorical variables now. If you think about the types of variables, you have the numerical type of variable where you have discrete and continuous. Okay, those are the variables where you have numbers. Okay, they can be discrete, that means whole numbers only, or they can be continuous where you can have your values will be within an interval, all the values within an interval. Those are the continuous type of variables. And then you have the categorical variables where you have several groups, okay, that you have in or several levels for a given variable. For example, blood type is categorical variable. Okay, you have the different categories, okay, including plus and minuses. Okay, so these are the different groups. So if you think about a sample of patients, you can find how many are there belonging to group A, how many are there to B, A, B, O, and so on. And you already know how to express this type of data graphically. You can draw, you can find the percentages of these from a pool of patients. You can find the percentages representing each blood group. You can draw pie charts, bar graphs, and you can summarize them using percentages. And if you want to compare these percentages, say, for example, for a given pool of patients, if you compare the percentage of patients with blood group A and B, whether these proportions are same or different, you know how to do the hypothesis testing, comparing two proportions. Okay, so likewise, you can do, you have already learned those type of analysis with categorical data. Okay. And now in this chapter 7, what we are going to do is we are going to look at several categorical variables at the same time and see whether we can find any associations related to these categorical variables. Okay, usually when you have 2 or more categorical variables for a given data set. Okay, say for example, we'll think about a certain genetic disease. Genetic disease. Yes or no. Okay, so you have a pool of patients who are suffering from a certain genetic disease and who are not suffering from it, and then you know their blood type. So if you want to figure out whether there is an association between the blood type and that genetic disease, you should be able to do that, right? So again, you have a pool of patients, you know whether they suffer from a certain genetic disease or not, and also you have information about their blood type, blood group. So you want to find whether there is an association with the blood type and the genetic disease. Okay, that means whether there's a high tendency for a certain blood type to have this genetic disease or maybe not. So you should be able to find those type of association. Now with both these variables, both are categorical variables. Both are categorical variables. And you are going to want to find whether there is an association. Okay, let's try another example. So you have
another.
Yes. Yes. Go on. You have a question? Okay. Yes. Right. Let's try another variable. Say. So this is one example. Yes, the second example. So you'll take another very common variable, categorical variable, gender, males and females, right? And then you have another categorical variable, let's say, whether they suffer from a certain heart failure. Okay, yes or no. Now again, you can find whether there is an association. Okay, say this is a common heart failure. So you want to find whether there is an association between being a male and a female and having that heart failure or this type of heart disease, whether there is an association between gender and getting this heart disease. Okay, you should be able to find that, right? So there are several methods that we can use to interpret or identify whether there are any associations in between categorical variables like that. Now, according to your context, radiography and radiology, can one of you give me an example? Or any example related to your area or any other example? Anybody who can come up with an example? It's okay if it is not 100% correct. I can fine tune it, no problem. Anybody who want to try? Manisha, can you give me an example? Oh, Gayan, what about an answer from you? Okay, how about this example? Okay, so I'll give you an example and we'll use it. Okay, I think I got okay. Having rheumatoid arthritis association with male and female. See, that's a good one. Okay, so let's write that example. Gender, thanks. Give me that's Manisha. Okay, thanks. So gender is male or female, and whether you are having rheumatoid arthritis. Yes or no? Okay. Different modalities and quality of the radiograph. Okay, so there's another one. We'll write that also. What is the meaning of modalities? I'm not familiar with that. Sashini, can you explain what does that mean? Different modalities. So what are the levels of the modality? Quality, let's say high, medium, low. Whether it is CTO, okay, CTO, that's more. That's now I can understand. Okay, so you have CT and MRI quality, let's say high, medium, and low. Okay, so we can test whether there is an association between getting a high quality, low quality, or medium quality, depending on the modality of your X-ray. Very good. Okay, so you have now we have a couple of examples. I'm sure you can understand the why it is important to know some techniques on how to identify this association. And usually from my experience about your final year research work for last few years, a lot of students come up with these categorical variables, and your final year research, it contains a lot of categorical data analysis methods. Okay, so this chapter will be very useful for you. Okay, I have another example from Michelle, I guess. The association with the cancer occur mostly to radiographers or non-radiographers. Okay, that's I think very important one for you. Okay, let's write that also. That's an important research if you can conduct and figure it out. Okay, cancer, yes or no? So let's say not rather than yes or no. Radiographers, yes or no? Let's say cancer prone. The higher probability to get cancer, high or low. Okay, so that's a good one. Okay, right. So very good. Thanks for everybody for these nice examples. So let's see how we can compare these type of variables. Okay, we are going to learn actually a couple of methods. So these are the techniques we are going to learn Now, these are not the only techniques. There are many other advanced techniques, but in your course, these are the techniques that I have to talk about. So we are going to talk about relative risk. Maybe you have heard about them. Relative risk, odds ratios. Then we are going to do the chi-square. This is chi, okay, Greek letter chi-square test of independency. Okay, so we write it as chi-square. Okay, so you have all these Greek letters, mu, epsilon, alpha, beta, gamma, and so chi is also a Greek letter that we use. So that is the chi-square test of independency. And in addition to that, we have prediction models that you can go for, but we are not going to talk about them in this course. These are a little bit advanced models. So we can go for binary logistic regression. These are prediction models, okay? Multinomial logistic regression. Okay, so in these prediction models, what you can do is you can predict the probability of being in a certain category based on some other independent variables. If it is only one variable, it will be just the binary logistic. If you have several other variables that will affect one variable, so you'll end up with the multinomial logistic. But anyway, we are not going to talk about them in this course, but we are going to look at these techniques: relative risk, odds ratio, and chi-square test of independency. Okay, right. So let's start with the relative risk. Relative risk and odds ratio. So those two actually goes together. So let's do both of them together. Okay. Usually the relative risk, we write it as RR, and odds ratio. So if you refer any if you refer research articles, I'm sure you will come up with these terms oftenly, especially related to medical research. Okay, right. So in order to explain the relative risk and the odds ratio, I'll use an example. Okay, it is easy with an example to explain these calculations. Okay. So this is about cancer versus calcium supplement. Okay, so in this study, a study was conducted using 100 cancer patients. Okay, so these are the cases, and 100 healthy group of people. So this will be your control group. Okay. So each of these groups, they are having 100 from each, so altogether 200. Okay. And it was found that (75) out of the cancer patients did not use calcium supplement. Okay, while, so I'm using just the shortened form supplement, while 25 among the control set, that is the healthy set, did not use this calcium supplement. Okay. Now we'll try to include this in a small table. Okay, you are very familiar with these tables now. Right, so I'll prepare the small table. So you have the disease group, that is the cancer. So you have two groups. These are the case and control. Okay, and then you have the risk factor. In this case, we are looking at our risk factor, which is the whether they take the calcium supplement or not. Okay, so here I have the risk factor, or you can say the exposure. So that is no calcium supplement, and then you have who take calcium supplement. Okay, right. Now let's try to find try to fill these values. Then you have the total, the row total and the column total. Okay. So if you prepare a table like this, what is the name that we give to these type of tables? Can you remember from the probability? What do you call this type of table? 2 columns, 2 rows. We have a special name for these type of tables. Can you remember? We call them contingency tables. And so this is a 2 by 2 contingency table, right? So you have 100 cases, 100 control, altogether 200. And it says that out of the cases, 75 did not take the supplement. So case, no calcium supplement 75, the rest 25 will go here. And among the control group, it says 25 did not use and the rest 75. So it's a coincidence that you have 75, 25 swept. Okay, so just a coincidence. Okay. Now, in the row wise also you have 100 in this case, right? So altogether there are 100 who did not take calcium supplement and 100 who took calcium supplement. Okay. Now, okay, so for this table, let's try to find the odds of the exposure, okay, or odds of the risk factor. Okay, so the first thing we are going to find is the odds of or you can say exposure, right? So the two levels are the calcium supplement not taking or taking. Okay, and for that you have two groups. What are the two groups? The case group and the control group. So let's find what will be the odds of exposure. Okay, the odds of exposure for the case group. How do you find it? You look at the case group. Okay, you find, okay, I'm going to name these cells as A, B, C, and D. Okay, A, B, C, and D. So for the case group, the odds we calculate it using A over C. Okay, so what is that? Among the case set, you take how many who did not take the calcium supplement, that is A divided by the number who took it. So you have A divided by C. So what will be the number? That will be 75 divided by 25. So you end up with the odds of the risk factor, okay, that will be 75 over 25, 3. And if you look at the control group, the odds of the risk factor, that will be the same thing. Now you divide the no calcium supplement over calcium supplement, that it will be now 25 over 75. So which will be B over D. Okay. Okay, so now why are we having the no calcium group at the top? What do you think? Because the risk is not getting it. Okay, so it is the common sense. You can figure that out. Not taking the supplement will be the risk factor. So that will go to the numerator. Okay, so not taking the supplement at the top, okay, versus taking the supplement, because if you take the supplement, the risk will be lowered. So the higher value of the risk, okay, should go to the top of your the ratio. Okay, so that will be 25/75, and you end up with 1/3. Okay, so that is just the odds. Okay, the odds of the risk factor. And then you can find very easily what is the odds ratio. That is the most important one. What is the odds ratio? The odds ratio is calculated usually for a 2x2 table like this. It is very easy. What you do is you multiply the cross. It is the cross. A times D divided by B times C. Okay, so that will be A times D divided by B times C. So what do you get? A is 75, D is 75, B is 25, C is 25, right? So can you find this number for me? Please calculate this and tell me the answer. That will be 9, exactly. So you'll end up with 9. Now the odds ratio is 9, and what does that mean? So that is the important thing. After you find the odds ratio, you can't just stop from there. You have to explain what is the meaning of this odds ratio, right? So what are we actually calculating? We are calculating the risk factor, right? We are calculating, or we are comparing in between cases and control based on the risk factor. Our risk factor is taking the supplement or not, right? And remember, we have the no supplement group at the top, and the supplement who take the supplement, they are at the bottom. So you are comparing the group who do not take supplement, okay, versus those who took the supplement. So you always compare top to bottom. Now, if you want to explain the meaning of this odds ratio 9, this is how you explain it. Okay, so what is our disease now? The cancer. Okay, so you can say that the risk of getting cancer is 9 times. Okay, or you can say if calcium supplement was not taken, the risk of getting cancer is 9 times compared to those who took the calcium supplement. Okay, so again, those who do not take calcium supplement, they have 9 times risk for getting the cancer compared to those who take the calcium supplement. Is that clear to all of you? So you are comparing no calcium supplement group to calcium group. Okay, and what you are comparing, whether they get the cancer or not. So I'll write it like this. Risk of, or you can say actually the odds of, okay, that's okay, risk of getting cancer is 9 times for those who do not take calcium supplement. You can say 9 times higher. It's more meaningful in that. 9 times higher for those who do not take calcium supplement compared to those who take calcium supplement. Okay, so that is how you explain the odds ratio. Okay? Usually you find the odds, but just odds will not explain both variables. So we always go for the odds ratio and compare the two categorical variables together. Okay, is this clear to all of you? How you calculate the odds ratio and then explain it? It's very easy. Okay, you just cross multiply your table and make sure which one comes top. Okay, which one comes top. According to that, you have to explain your odds ratio. In our table, we have the no calcium group at the top, and the next level is the calcium group. So you always compare the risk no versus calcium. Okay, no calcium supplement versus calcium. Okay. Right. So the relative risk is also very similar to, it is like odds ratio and relative risk are actually the same thing. Odds ratio is calculated when you already know your records, like you already know these patients have cancer, these patients do not have cancer. You already know they took the calcium supplement, and you already know these people did not take the calcium supplement. This group took the calcium supplement. You already know. So in such situations, we go for the odds ratios. That means these type of information, they are now available actually. Okay, or you have this current situation, right? The relative risk is used when you are doing something for future. Okay, you do not know whether the disease has already occurred or not. Okay, there can be studies like that, because you start with a certain treatment and you are waiting for the results. Okay, so the results will be there in future, but you can predict, okay, whether there is a risk or not. So in such situations, we give the name relative risk rather than the odds ratios. Okay, so when there are different examples, I'll explain how to use the relative risks rather than the odds ratios. But I think in your situation, just focus on odds ratios. Okay, so don't worry about in between these terms, risk ratios, odds, relative risk or odds ratios. For now, just think about, you already have this information, the study is already conducted, and all these numbers are there. Okay, then you can go with the odds ratios. Okay. Now you may be wondering, now in this example, we have only 2 levels for both groups. It is a 2 by 2 table. Disease group, you have case control. Risk factor, you have no calcium and calcium. So only 2 levels, and you have 2 by 2 table. And when you have 2 by 2 tables, calculating odds ratio is very easy, because it is just the AD times AD over BC, this cross multiplication. But when you have more than 2 variables, sorry, or more than 2 levels, at least in one random variable, then you can't use this simple calculation. Okay, you can't use this simple calculation. For that, your calculation becomes a little bit complicated, and hand calculations we don't recommend. If you use a statistical software, the odds ratios will be readily calculated for you. What you have to do is just pick the number and explain it like we did in these words. Okay. So when you have, say, there are 3 levels in one group and there are 4 levels in one group, you'll end up with 3 by 4 table. Okay, there will be 12 cells. And calculating odds ratio in such situations using a hand calculation like this, it is not possible. But you can enter the data set into a statistical software, and you can ask the software to calculate the odds and odds ratios for you. And these calculations will be nicely prepared, and you will see odds ratio number displayed as the output. And you can pick it and explain it according to the way you enter the data. Okay. So for now, just know that the 2 by 2 tables, this is how you find the odds ratios. Anyway, after you find the odds ratio, this is how you explain it. Okay. So is this clear to all of you? How to get the odds ratio? So let's try another one. Okay, so this one I'll explain both the odds ratio and the relative risk. Right. Here's the example. Okay, so this is a study about, we're going to identify the relationship between smoking and lung cancer. Okay, smoking and lung cancer. Right. So here's the table. So what is the risk factor in this case? What is the risk factor or the exposure in this case? The risk factor is whether they, yes, smoking, whether they smoke or not. So let's say smoking, that is the risk, smoking is the risk, and non-smoking. Okay. And what is our disease? Whether they got the lung cancer, this is the lung cancer. Actually, they are finding whether they were diseased or not. That means whether they died due to lung cancer. So let's say death due to lung cancer. Okay. Rather than saying, let's say death due to lung cancer. So you have yes and no. Okay. So these are the values. 900, 150. Right. So this is the these are the numbers. Okay. Now, can you find how many died due to lung cancer and how many so due to other reasons? Okay, so none means there were some deaths in this cohort, but those deaths were not due to lung cancer. So can you find the totals for me? So you have 1,000 smokers actually, okay, and another 1,000 non-smokers. Out of the 1,000 smokers, 900 died due to lung cancer, 100 not. So that is how you can explain it. And you have 1,000 non-smokers. Out of them, 750 died due to lung cancer, 250 not. So let's try the totals. Altogether, 2,000. Okay. Right. So I'll explain how to find the relative risk in this case. Okay. Now, why are we, even you can find the relative risk for the previous example, but anyway, okay, so let's do the relative risk and both odds ratios in this case. Okay, let's find the odds ratio first. Okay, you already know how to find the odds ratio. That will be cross multiply. Can you find it? 900 times 250 divided by 150 times 100. Can you find that? Okay, so I have 3. Yes, the odds ratio is 3. Can you explain it? What is the meaning of odds ratio 3? you can say the odds of dying due to lung cancer is 3 times higher for smokers compared to non-smokers. I think I got the, okay, so 3, okay, is that clear? You can say odds or risk, it's okay. Odds of death due to lung cancer is 3 times higher for, you are comparing smokers versus non-smokers. So smokers come first, higher for smokers compared to non-smokers. Okay, I think it is very clear. The odds of death due to lung cancer is 3 times higher for smokers compared to non-smokers. Okay, now let's find the risk ratio. Now it is going to be a little bit different. Okay, this is how you find the risk ratio. You take the risk factor, the risk factor that you're looking at, that is the smoking. How many yeses, how out of the total, right? How many yeses out of the total? Out of 1,000, there are 900 smokers. So you have 900 out of 1,000 at the top. And then you find how many non-smokers out of the total. You have 1,000 and out of them, there are 750. So this is how you calculate the risk ratio. Okay, how do you do that? You take the risk factor, okay, only the risk factor. Look at the risk factor, smokers and non-smokers for both, whatever the 2 levels. You find how many, now in this case, our disease is getting lung cancer. Yes. Okay, how many yeses are there out of the total? For smokers, then you divide it by the ratio of yes out of the total for the non-smokers. So that is very simple. The 1,000 will cancel out and you'll end up with a 900 over 750. So what is that number? Okay, so it is 1.2, right? It is 1.2. So may I go back to the previous explanation and make this odds of getting, otherwise you will confuse with odds of getting cancer. Okay, so rather than taking risks, because with the risk ratio, we are going to explain or use the word risk, otherwise you will get confused. Okay, now how do you explain this 1.2? 1.2. There are many ways that you can explain this. Okay, you can say the easiest way is when you have 1 times 2. If you think about the 1 as 100 and 0.2 as the percentage, this is like 120%, right? 120%. That means you have 20% more chance or 20% more risk. Okay, so usually with the risk ratio, you can explain that the risk of death, okay, due to lung cancer is 20% higher for smokers compared to non-smokers. So that is how you can explain the risk ratio. Yes, that is okay. Yes, you can explain the smokers prone to lung cancer 1.2 times compared to the non-smokers. That is one way to say it. You can say smokers have smokers are in risk of dying from lung cancer 1.2 times compared to non-smokers. When you say 1.2 times, it is kind of blurred. The idea, you can't get it very clearly, right? So it is better, you can say smokers have 20% more risk than non-smokers. to end up with death due to lung cancer. Okay, so that is a better way to explain. Even if you say the smokers had 1.2 times risk of dying from lung cancer compared to non-smokers, that is also okay. But usually we use this way of writing it. Okay, so you have 100 and extra 20%, so 20% more risk than the non-smokers. Okay, right. So that is how you calculate odds ratios and the relative risk. Okay. So is this clear to all of you how to do these calculations? Right. Now these are simply proportions kind of, right? And the probabilities, percentages. So the odds ratios and relative risks will give you some information about the association, but it is not very strong evidence, okay, showing that there is an association. So if you want to show statistical evidence, okay, whether there is an association between two variables or not, you have to go for a certain hypothesis testing. Okay, so that means you have to develop a hypothesis, find a test statistic, find the p-value, and then based on the decision, rejecting H0 or fail to reject H0. That is a more firm way of confirming your evidences. Okay, so you do risk ratios or odds ratios, but you have to confirm, or you have to do a confirmatory analysis in order to prove these things statistically. So therefore you have to go for this chi-square test. Okay, so that is the next one. This is more towards the confirmatory analysis. So we go for the chi-square test of association or independency. Okay, we use all these names: chi-square test of independency, chi-square test of association. All of them are they refer to the same thing. Okay. Now let's go back to our same example. Let's look at the cancer and the calcium supplement one. Okay. So what are we going to do is we are going to test whether there is an association between the two variables or not. So our hypothesis will be there is an association. Should we do it the other way? It's independent. I'll use a common one. Okay. Two variables are independent versus alternative. Two variables are not independent. Okay. So if they are independent, that means there's no association. If they are not independent, okay, if they are independent, that means there's no association. If they are dependent, that means there's an association. Okay, so it is the same thing if you write it like this. There is no association between the variables versus HA, there is an association. Okay, so you can either use the first one or the second one, it doesn't matter, right? But make sure you write it in the correct way. Okay, no association is H0, not independent is HA. So you have to be very careful. I recommend you stick with only with one thing. So you want end up with wrong interpretations. Okay, so either you can use two variables are independent versus not independent. It is the same thing saying no association versus there is an association. Okay, right. So let's look at our example. Okay, before that, I'll give you the test statistic. I think that is better. Right, so that is our hypothesis. Then our test statistic. This is going to be a chi-square test statistic or chi-square number. So we refer to the same A, B, C, D, right? We have the 2 by 2 table. Right? And this will follow. The degrees of freedom will be n minus 1 times n minus 1. That means the number of columns minus 1 times the number of rows minus 1. In this case, it will be 2 minus 1 times 2 minus 1. We are looking at only a 2 by 2 table. So it is going to be degrees of freedom 1. Okay, so I'll show you the chi-square distribution later, and I'll show you how this degrees of freedom is related to the table. Okay. Anyway, the test statistic, this is how you calculate it. Your table with that A, B, C, D table, right? You have the risk factors in this side. This is in the other side. Okay, so these are the same A, B, C, D. Okay, right. You don't have to remember these equations. I always tell you a formula sheet will be provided. So nobody. Okay. And again, the calculating of the test statistic, this hand calculation is possible only for 2 by 2 tables. But when there are many levels, again, you have to use the software. It will give you the test statistic and a p-value will be provided. You can very easily interpret your result. Okay. Right. So let's use our example. Right. So maybe I'll write it again, the table. We have the disease, cancer, case and control. And then we have no calcium supplement and the calcium supplement. And these were the numbers we had. A, B, and C, D. Right. Shall we do the calculations? Okay, so what is our hypothesis? We'll use the independent. Right? Cancer and calcium supplement are independent versus HA, cancer and calcium supplement are not independent. That is our hypothesis. Then our test statistic. Which is going to be a chi-square number, right? What is it? This is very easy. See, AD cross multiplication, AD minus BC. Square it. Then you add all these four cells, A plus B plus C plus D. Then you divide. This is the A plus B, C plus D, A plus C, B plus D. So you divide by these four subtotals actually. So you have at the top, at the bottom, A plus B, C plus D, B plus D, A plus C, right? So can you see that? So that will be the subtotals. Okay, so you multiply all four values. Right, shall we calculate this one? 75 times 75 minus 25 times 25, square it. A plus B plus C plus D, that will be 200, right? And A plus C, all of them are 100, right? B plus D is also 100. C plus D is also 100. All of them are 100. Okay, can you find the test statistic? Okay, 50. Is that correct? Any different answers? Any other different answers? Okay, I guess that is correct. I don't have the answer actually, so. Can all of you get that number? 50, okay, so that's correct. Right, now we have to find the rejection region, right? If you use the software, the p-value will be there, but well, we'll use the rejection region. You are familiar with that now. Now our test statistic is a chi-square distribution. Now it is a new distribution. We have learned the normal distribution, we have learned the binomial, we have learned the t distribution. Okay, now this is a new one, a chi-square distribution. Chi-square distribution is a skewed one. It is very different than the normal distribution and the t distribution. Okay, you know the normal and the t distribution, they are nice, symmetric, bell shape, symmetric about the mean. Okay, the left tail and the right tail, they are symmetric. Okay, so you have both positive and negative Z scores or T scores, easily calculatable. But the chi-square distribution is a skewed distribution like this. It is skewed and possible values are always positive. The chi-square values are always positive. You cannot end up with negative values for chi-square density. Okay, so always they are positive, and it is a right skewed distribution like this. Okay, and when we do hypothesis for chi-square distribution, our rejection region, okay, according to the alpha, can you remember alpha is our significant level. So if you are testing, or if you are testing this hypothesis at 5% significant level, alpha will be 5%. Okay, so we are having, we are usually using this one tail test. Okay, right. So let's look at the chi-square distribution table. Right. So here's a chi-square table. See, look at the distribution. The shaded area is equal to the chi-square alpha. So whatever our alpha value is this rejection region. And if you look at the chi-square table, it has the first column is the degrees of freedom. So that is the degrees of freedom I showed you, that depends on the number of levels in each categorical variable. In our case, we had 2 levels in each. So 2 minus 1 times 2 minus 1, just 1, degrees of freedom 1. So this is the line we have to read. Okay. So if this is the area, the colored area, right? So we need the chi-square. Now, if you think about alpha at 5%, so that will be 0.05. Okay, so whereas chi-square 0.05. Can you see this column? Right, so you have chi-square 0.05, degrees of freedom 1. Here's our critical value. Okay, is that clear? That is our critical value, and it will differentiate the rejection region and the non-rejection region. Okay, so our alpha 5%, 0.05, you pick this column. Okay, and the degrees of freedom 1. So where they cross, it is 3.841. So if I go back to our example, so this critical value is 841. 3.841. So everything beyond this line will be in the rejection region. Okay. Now let's go back and get our test statistic. What is it? 50. Where is 50? It will be far away somewhere over here, right? So it is obvious that it is in the rejection region. So what is our conclusion? We can reject H0. Okay. So very simple. Read in the chi-square table. It is not hard. You pick the alpha level. You pick the degrees of freedom. Then you can read the chi-square table. Okay. So you find that the rejection region is beyond 3.841. Okay, so this is with degrees of freedom 1. Okay. Is it clear why it is 1 to all of you? Right. So when you say you reject H0, this is gone. So what does that mean? Cancer and calcium supplement, whether you take it or not, are not independent. Right, so you see that there is a dependency, right? Or you can say there is an association between getting cancer and not taking or not taking the calcium supplement. So shall we write it in? Shall we write our conclusion? It can be concluded at 5% significant level that calcium supplement how do you say usage, or what is the nice word to say it? Okay, I'll explain the chi-square table again. Okay, the calcium supplement, say and exposing to cancer not independent. Or you can say, we can conclude at 5% significant level that there is an association exposing to cancer taking calcium supplement. Okay, so either way you can write it in this form or this form. It's up to you. Okay, whatever easier for you, you can go with that. Okay, right. So I'll explain how to get the chi-square the table again. Right. So in this example, for our two variables, variable 1 and variable 2, I'll say Variable 1 is this cancer disease, and 2 is the calcium or no calcium. You have 2 levels. Variable 2 also you have 2 levels. So our degrees of freedom will be the number of levels minus 1 times number of levels minus 1 for variable 1, variable 2. Okay, so in this case, it will be 1 times 1, which is 1. So our degrees of freedom is 1 if you have 2 by 2 table. Okay, and we are going to perform our hypothesis at alpha 5% significant level. Okay, that should be given. Okay, so if you think about a question, it will tell you test at 5% significant level whether there is an association between calcium supplement and cancer, right? Something like that. So you know that your alpha will be 5%. So you go to the chi-square table. Okay, so in this table, first you get the degrees of freedom from the first column. Okay, you can see it goes up to 100. So you get the degrees of freedom, our case it is 1. And our alpha value is 5%. So the chi-square table, can you see the colored area? That is the rejection region. That is our alpha level. Okay, our alpha is 5%, which is 0.05. So this is how we write it. So find chi-square 0.05. This is the one, right? Chi-square 0.05. So you can see all possible tail values. 0.025 is there, 0.01 is there, that is 1%, and 10% is there, that is 0.1. This is 10%. This is 5% alpha. This is 1% alpha. This will be 10% alpha. Right? Usually those are the columns we will need. Right? If we go for a two-tail test, that is where you end up with alpha 0.025, but with this categorical data analysis, we don't end up with that. Okay, only the one-sided test. So you find the corresponding column for the alpha level. So that is chi-square 0.05, degrees of freedom 1, where they cross, you end up with 3.841. So this is 3.841. Okay, so that is what we entered in our rejection region, 3.841. Any test statistic beyond this 3.841 will be in the rejection region. Anything less than that will be in the non-rejection region. Our test statistic is 50, and it is very obvious it is far away in the right tail. So it is in the rejection region. Therefore, we reject H0. So when you reject H0, you can conclude that these two variables are not independent. Not independent means there is an association. There is a dependency. Okay. So you can write the conclusion according to that. Is that clear?
Yes, ma'am.
Okay, so let's do one more example for today. Okay, one more example. Right. Okay. This is again a very very important research. We want to find whether there is an association folate intake during pregnancy and premature births. Okay, so here's the data set. Okay, so our risk factor here is whether you take folate or not. Okay, so you have no folate during pregnancy, and you have taken folate. And then you have the premature births. Yes or no. Okay, so I'll give you the numbers. Some numbers where you can easily calculate. Let's see. Okay. Right. Test at 5% alpha. Test whether there is an association between premature births and folate intake during pregnancy. Okay, so let's start with writing the hypothesis. Premature births and folate intake during pregnancy are independent versus HA. I'll just write not independent. Okay. So what does that mean again? There's no association between premature births and folate intake versus there is an association between folate intake and pregnancy. Okay. Right. So shall we calculate the test statistic? A, B, C, D. Right. So you can find the subtotals also. Okay. Can you find the number? Okay, anybody who has the answer? Again, this case, the degrees of freedom will be 1 because we have only 2 levels. 2 minus 1 times 2 minus 1. Okay, so it is 52.50. Okay. Right. So again, it is obvious that it is going to be somewhere far away in your right here. This is again the same thing, alpha 5%, degrees of freedom 1, the rejection region will be beyond 3.841, like the previous case. So you can clearly see that is again the rejection, rejecting H0. Okay, so when you reject H0, what does that mean? You can say that the premature births and folate intake, they are not independent. That means there is an association, right? So let's write it. We can conclude at 5% significant level that there is an association between premature births and folate intake during pregnancy. Okay. So is this clear to all of you, this example? So as I mentioned, for 2 by 2 tables, you can easily find these calculations. Okay, if it is beyond that, you have to use a software. Say, for example, when you have to compare the 2 variables, our variable 1 is, let's say, like that example one of you gave me, the quality, high, medium, and low. And the modality of the, whether it is CT or MRI, I guess. So there are only 2 variables. Here you have 3 variables. Next one you have 2 variables. Then what is the degrees of freedom? 3 minus 1 times 2 minus 1, which is 2 times 1, 2. Then when you read the chi-square table, you have to use the degrees of freedom 2 with whatever the alpha level. Okay. Again, these type of tables, then you'll have 3 columns and 2 rows, and hand calculations, it's not easy. So you're not going to do that. But if you use a software, you can easily get the p-value, even the test statistic and the p-value. By looking at the p-value, simply you can make the decision. Okay. So that is what I wanted to talk to you today about the categorical data, how to find the odds ratios, the relative risk, how to interpret it, and then how to confirm your findings using the hypothesis testing, that is the chi-square test of association or chi-square test of independency. Okay. So any question so far with this content? Okay, so when we get a chance to do the practicals, I'll show you how to do other dimensions and how to get the output and using p-value, how do you make the decision, okay, when you have more than 2 levels in your variables. Okay, all right. Any other questions? Right. So if you don't have any other questions, we'll stop for today. The next lesson I will discuss about how to compare or how to identify associations when you have 2 continuous type of variables. These are 2 categorical variables, but when you have to compare 2, or when you have to find association between 2 continuous type of variables or numerical variables, what are the techniques that you have to use? Okay, so that will be our next lesson. That will be chapter 8. Okay, then I'll stop for today and I'll upload these notes and the video lesson for your reference.